Hello, welcome to week 2 of CEE294. This week we're going to look at using arrays in MATLAB. So again, some of this may be review for many of you, but there should be some additional information this week. Really feeling very confident in your ability to manipulate arrays in MATLAB and understanding the details of arrays, I think is super key to being able to write a really well-organized and functional programs. So let's get started. So here we have the week 2 information that you need to solve the examples. So we're just going to begin with looking at a simple row and column vector, something that you're mostly probably familiar with already. So for example, I'll start with R. I can write a simple row vector in MATLAB by just typing in the elements separated by a comma. We could also just put spaces there to separate the elements. I tend to use commas when teaching because you can't see the spaces very well, but when I'm writing my own code, I usually use the spaces. Column vectors are those that are separated with a semicolon instead of a comma. And if we go ahead and run this, you can see very quickly that the row vectors are horizontal and the column vectors are vertical. And this is important because vectors, their direction really matters, especially when we're doing vector matrix multiplication. We can also easily change a row vector into a column vector by just transposing it. So for instance, I could go ahead and take the row vector I already have, put an apostrophe there, and this is going to transpose my vector. So now I could just run this, and you'll see now my row vector looks like a column vector. We can combine these two things to make full matrices and arrays, and MATLAB can deal with multiple dimension arrays. We're really just going to work with 2, possibly 3 dimensions, and leave it at that. But MATLAB can certainly do more than that if needed. So I could go ahead and write in a matrix. So in this case, I will first type in the row, and then I will use a semicolon to drop down to the next row. So now I'm starting to fill in columns, basically. And I think you should just consider that a comma makes you move to the right, a semicolon makes you drop down. All right, we can go ahead and run this, and we can see we have a matrix. And if we're looking over on our workspace, we can double click on any one of these vectors, double click on the yellow box there, and it should pop up. And you'll see here, it gives me the dimensions, the 3 by 3, and then it also fills this into a spreadsheet. And MATLAB, actually, we can sync it with Excel as well and use that to help us if we're evaluating or manipulating arrays further. So I can just close that and come back. Oh, so I closed out my entire file on accident. So I'll just come back over here and reopen. There we go. Right, so matrix multiplication, this is important and something that comes up quite often in MATLAB. We want to multiply, say, 2 very simple vectors. So I have v1 and say I have v2. And I want to multiply v1 times v2. And if I run this, you see you're going to get an error, actually. And it's going to tell us that these dimensions don't work. You can't multiply these 2 vectors together because of the dimensions. So what are the dimensions of these? This is a 1 by 2, meaning 1 row, 2 columns. This is also a 1 by 2, 1 row and 2 columns. So what I'm doing here is multiplying a 1 by 2 times a 1 by 2. Now we know in MATLAB that in matrix multiplication, the interdimensions have to match for this to be able to work. So this code does not work. If I want to multiply these 2 vectors together, I can do it one of 2 ways. Actually, one of 3 ways. I can take v1 times v2 and transpose v2. So now I have a horizontal vector. I have my 1 by 2 times the column vector 2 by 1. And now we can see that the inside dimensions match, and the final answer should be the outer dimensions of 1 by 1. We could do this the other way around. And that is transpose the first vector. And this becomes a 2 by 1, 2 by 1 times a 1 by 2. So now the inner ones match, and the outer dimensions will give me the final answer dimensions. The third thing that we can actually do with this is go ahead and rewrite this as V1 dot times V2. So what this essentially does is this is going to allow me to multiply the 1 by 2 times a 1 by 2, and the final outcome in this case should also be a 1 by 2. So here we have a 2 by 2, and here this would be a 1 by 1. And so if you run it, you'll see what's going on here is it's taking the first element times the first element of the two vectors and the second element times the second element. So this is what we call element by element multiplication. And it's really important because oftentimes we're not looking to do real vector multiplication. What we're looking to do is actually just do this element by element, usually because we have data and we're trying to manipulate the data. Similarly, you could do this with exponents. So say I wanted just to square one of these. This would give me an error. But if I put the dot there, what I'm telling MATLAB to do is just square each of these elements individually and then stick them back into the array. And so again, this dot is coming before the operation. So it's the dot and the operation that go together. All right. Matrix division. Let's take a look at matrix division. So quite often we want to solve some type of equation in MATLAB when we're dealing with, say, mechanics or kinetics. And a pretty common one would be something like a stiffness matrix times a displacement equals a force, right? So this is like your typical spring equation here. And usually we have, say, the stiffness matrices and the applied forces. So if I say, this spring has the stiffness, I'm going to apply this force. What I really want is the displacement, right? And so what we are used to writing then to solve something like this would be x equals F divided by K, right? Now in MATLAB, this is scalar multiplication, scalar division, basically, sorry. However, if we are dealing with K and F as systems, so I might have multiple springs, or if I've taken my system and divided it into parts, like as in a direct stiffness method or a truss, I might have multiple members. I'm going to have multiple values for that stiffness and force. And this one would be a matrix, and this one would be a vector. And then the displacements would be the displacement at, say, each of the nodes of the truss. And so what I don't want to do is just scalar division. I want to go ahead and do a matrix division or actually solve this. So what we would need to do to solve for x is actually take the inverse of k. And so what you would essentially do is apply k inverse to both sides. Okay, and this would be times x equals, and then on this side, you would have K inverse times F. So this might be a little bit of linear algebra that you haven't seen before. It's not too important that you go into this further, but the important thing to know is that if we want to solve something like this in MATLAB, what we're going to do is basically use a backslash instead of a forward slash or forward division. So I could write it like this instead. So let's try that. So let's go ahead and say we have K equals, and let's just, any stiffness matrix is fine. And there we go. And then our force, any applied force. Now, this could be problematic if I come up with some numbers that make something singular. Let's just make the force a little larger then. Should be okay. Right, so you'll note that the matrix, so when I run this, I have K looks like this, and there's my force matrix. And so my displacement now should be like this. Oops, did I get it backwards? There we go. Yeah, so my displacement is like that. So now we should go ahead and test it out. What if I have K times X? I'll just call this test equals K times X. This should get back to my force there, right? So this is how that we would go ahead and solve for the displacements. We're just using this backslash instead of the forward slash, all right? All right, array creation. There are a lot of other ways to create arrays in MATLAB that can make things a little faster for us. So instead of typing out all the elements, I can have MATLAB do a lot of that work for me. So for instance, I can go ahead and type in the first element of my array, say the spacing, and then say the last element. And I can run that, and you can see, so it should be first, spacing, and then last. And so we could change the spacing, say I wanted 2. Now it's going to take steps of 2. There are also some other things, ones. So let's see. Ones will create arrays of ones. So this would be ones, and say they wanted a 2 by 3. That will create an array of ones like that. And we could also use this command I, and this is going to create an identity matrix with all ones on the diagonal like that. All right. Oh, those were my built-in arrays, so we will just leave that. And then array manipulation. Now that we have our arrays made, we can extract elements from those arrays and combine elements together to make bigger arrays. So for instance, if I wanted to pull this out of this C matrix, if I wanted to pull this top corner, I could call it C corner. I can pull it straight from the C matrix by calling the name of the matrix and then specifying which rows and columns I want. So I want rows 1 to 2 and columns 1 to 2. So this is, just make yourself know, name, and then rows, and then columns. And, we could just pull a single element. So for example, C element, I could just say, you know what, I want the third row and the fourth column. You could just do that. Third row, fourth column, just like that. Or you can pull a range of rows and columns. Now, once you've done that, you can also concatenate matrices. So say I want to stick 2 matrices together. So, maybe I want to, let's go ahead and make B a 2 by 4 instead. Okay, so now I have B, and what I want to do is just stick it onto the bottom of C. So how can I do that? Okay, so I'm going to take D, and I want C, and then what I'm going to do essentially, and you can put this in square brackets. Square brackets always denote this is going to be an array. C, and then I want to drop down a row and put in B. And so remember, the semicolon means drop down a row. So when I do that, then I can add it together. I could also have put it on the side. So perhaps we could do something like that, D2. Now the dimensions have to match. That's super important. So if I just try to put comma B here, it may fill in with zeros. Sometimes it will give us just a fill in with zeros. Sometimes it will tell you, okay, those arrays are not consistent. But if I actually transpose B, then it will turn it around, and so the 4 is coming down, and it allows me to stick it on the end. All right, the last thing I want to show you is that you can determine the size of a matrix. Say I have D2, and I want to know how many rows and columns it has. So I could go ahead and say, tell me the rows and the columns, and I can just use size of D2, just like that. It's a built-in function, and you're perfectly welcome to use this built-in function to help give you something like the number of rows and columns.